Hi, my name is Brian Buckley, and I'm the Executive Director of EOHSI, but I'm also the Chemical Analysis Facility Core Director. The Chemical Analysis Facility, what we call the CAF, provides analytical support to our investigators here. We're primarily a small molecule mass spectrometer shop, but we do analysis of metals and organometallics as well. We look for biomarkers, we help people quantify exposures, we look for nutritionals and new drugs as well. And I hope if you've come here, you come looking for potential solutions to your analytical problems. We have an outstanding staff made of 3 PhD analytical chemists who all head separate sections and all have different responsibilities within the CAF. Anita Brinker primarily deals with nutritional analytes, but she also does things like xenobiotics and other compounds that are LC or liquid chromatograph based for analysis, including lipids. Kathleen Doherty comes to us as a geologist by training, but is an expert at ICP-MS analysis for metals and organometallics. Hilly Yang has been classically trained in proteomics, but migrated to GC or gas chromatograph mass spectrometry and really does all types of organic analysis, especially methods development. I hope that we are the answer to your needs for chemical analysis on the Rutgers campus.
In this lab, we use a high-resolution magnetic sector ICP-MS, and ICP-MS stands for Inductively Coupled Plasma Mass Spectrometer. And what it does is it's a highly sensitive instrument that's capable of measuring trace quantities in metals ranging from the part per trillion level all the way up to the part per million level. This instrument is housed in our clean lab, which has filtered air, which reduces the level of contaminants to our samples and allows us to measure very, very small quantities. What's great about an instrument with these capabilities is that we can couple it to various different auxiliary applications. For example, we can use an ion chromatograph, which allows us to speciate different forms of metals. So, for example, we can distinguish between the toxic forms of metals such as arsenic or chromium. We can also couple it with a laser ablation system, which allows us to make in situ analysis of a solid sample. And what's great about that is that we can look at changes in the growth or the development of an organism or, say, an individual when we analyze a biomarker sample like a tooth or a tissue. Essentially, we can analyze nearly any element on the periodic table in nearly any sample matrix. And so we kind of like to think of ourselves here as problem solvers for the entire department. Most recently, we've been working on improving our capabilities of making isotopic measurements. And this is used for source apportionment, which is looking at the characteristics of different environmental contamination sources and using very high precision compositional information, which is based on the isotopic ratios measured in these sources, to be able to determine what is contributing to an exposure in an individual. Our labs work to address a broad range of questions from toxicology and heavy metal exposure to environmental contamination. So some of the projects that we're working on include using ICP-MS to quantify the accumulation of heavy metals in target organs. And these are to investigate how certain drug transmitters might protect against the accumulation and toxicity of a particular element, such as cadmium. We also analyze samples from the human body. So one of the projects we're working on is looking at human placental samples to understand fetal growth restrictions or fetal growth in general by looking at the accumulation of heavy metals in the mother's placenta. We're also working on projects that look at heavy metal exposure through e-cigarettes or vaping. And so we find that using e-cigarettes can actually increase the exposure risk for a person for heavy metals.
Currently we have several different projects ongoing. One of them has to do with analysis of a group of compounds called anthocyanins. These are the compounds that are responsible for the coloring of fruits and flowers, and they're also of interest right now because they have some anti-inflammatory, antioxidant activity. So there's a group on campus that is looking into using cherry juice as a potential treatment for gout, and they're interested in measuring the levels of these compounds in the plasma of their subjects. So that's one of the projects I'm working on right now. The other project has to do with looking at levels of a class of compounds, mycotoxins. These are compounds produced by fungi that get into some crop plants like corn and other things, and then the animals that eat the corn may have some levels of these as well. These compounds have estrogenic effects, so in other words, hormone effects. So there's interest in determining whether people who eat products containing these compounds may, particularly pregnant mothers, if these compounds get into their placentas and somehow affect the development of their babies. So that's the other project I'm working on right now.
This is Hilly Yang, Associate Director of Method Research over here. I've been studying about a lot of method developments in disease mechanism and cancer prevention studies. And also as a pulse scientist who apply ion trap mass spectrometry into the unknown environmental sample compound discovery, there is a lot of method development also has been done by under divisions. Another area I'm focused on is in silico mass spec software development, and then for metabolite identification and then metabolomics. The current project I have is for point of care diagnostic of COVID-19 by using so-called electronic node technology. We have we developed a lot of target method already, and then we'll transfer this method into small tiny eNode device so that they can detect rapidly in point of care sites. For more information, please visit our EOHSI website and our Chemical Facility Center website. There are a lot of good projects has been done. You will see a lot of valuable information over there.